Problem solving and reasoning for technology. Introduction. This lesson contains basic intuition, proof, and certainty in mathematics. Learners will also know how to solve problems using Polya's method. For the learning outcome, at the end of this lesson, the learner should be able to use different types of reasoning to justify statements and arguments in real-life situations. Let's start with these key terms. First is premises. A premises is a statement that is assumed to be true. Arguments, attempting to provide a reason for a conclusion. Syllogism, the formal structure of logical argument. Major premise, it's a general statement that assumed to be true. And the minor premise, it's a specific statement assumed true. So these are the key terms for this topic. Intuition, proof, and certainty. Intuition, quick and immediate apprehension or reasoning. For proofs, the strength of evidence that compels acceptance by the mind of truth or fact. Certainty, the quality or state of being certain, especially on the basis of proofs. The two major types of reasoning, deductive and inductive, refers to the process by which someone creates a conclusion as well as how they believe their conclusion to be true. Let's start with deductive. Deductive reasoning. Deductive reasoning requires one to start with a few general ideas called premises and apply them to a specific situation. Recognize rules, laws, theories, and other widely accepted truths are used to prove that a conclusion is right. The concept of deductive reasoning is often expressed visually using a funnel that narrows a general idea into a specific conclusion. So in deductive reasoning, the premises starts with a general idea and then you will create a specific conclusion. Let's have examples. So in this column are the premises, and in the next column are the conclusions. Let's start with the first premises. All muscles are made out of living tissue. That's the first premise. All humans have muscles. That's the second premise. What will be the conclusion? Therefore, all humans are made out of living tissues. Usually, the conclusion starts with the word thereof, or I conclude, and so on. For the second premises, all prime numbers are odd. Then, 2 is a prime number. What do you think is the conclusion? The conclusion is, thus, 2 is an odd number. Note that this is a not true statement. Because of the first premise, all primes are odd. The next example, the drafting major class was assigned to draw a plan for a new building. Alex, draw a plan for a new building, and Alex is also a student. If Alex is a student and he draws the plan for a building, then the conclusion is, then Alex is a drafting major. So as you can see in these examples, all starts with the general premises or general statement. Then the conclusions are specific statement. The next reasoning is inductive. Inductive reasoning uses a set of specific observations to reach an overarching conclusions. It is the opposite of deductive reasoning. So, a few particular premises create a pattern which gives way to a broad idea that is likely true. All forms of inductive reasoning, though, are based on finding a conclusion that is most likely to fit the premises and is used when making predictions, creating generalizations, and analyzing cause and effect. Just as deductive arguments are meant to prove a conclusion, in inductive arguments are meant to predict a conclusion. So as you can see, the difference between the two reasoning, in deductive, you need to prove the conclusion. But in inductive, you need to predict the conclusion.
For the examples, we have premises and also the conclusions. First example is 25 is divisible by 5. 30 is divisible by 5. What do you think will be the conclusion? Therefore, numbers that end with 0 and 5 are divisible by 5. Since both premises are true, then the conclusion will be true. It is also because the rule for divisibility. Let's have the next example. My neighbor's cat hisses me daily. At the pet store, all the cats hiss at me. Then the conclusion, therefore, all cats probably hisses me. For the last example, in MPC, there are students who studying welding and fabrication. Alan most of the time bought steels for his requirement in his class, and John always have grinder in his bag. If Alan most of the time bought steels and John always have grinder in his bag, then Alan and John are students of welding fabrication. So as you can see, the premises are the specific statements. Then the conclusions are the general statements. So these are examples of inductive reasoning.
Let's have this method, which is called Polya's method. So Polya's method in problem solving. In 1945, George Polya published the book How to Solve It, which quickly became his most prized publication. It sold over 1 million copies and has been translated into 17 languages. In this book, he identifies four basic principles of problem solving. So he has four steps or four principles to solve a problem. Let's have the first principle. The first principle, understand the problem. You got obstructive your efforts to solve problems. It's because you don't fully understand the problem, or even in part it. Polya taught us to answer the following questions while solving problems to understand it. First, do you understand all the words used in stating the problem? The next one, what are you asked to find or show? Can you restate the problem in your own words? Can you think of a picture or diagram that might help you to understand the problem? And lastly, is there enough information to enable you to find a solution? So these are the questions that Polya gave us for us to be able to understand a specific problem. The second principle is devise a plan. Polya mentions that there are many sensible ways to solve problems. The skill of choosing an appropriate strategy is best learned by solving many problems. A partial list of strategies is included. You might uh, look for your own strategy here. You can guess and check, draw a picture, use symmetry, word backwards, solve an equation, look for a pattern, eliminate possibilities, use a model, use direct reasoning, be ingenious, make an orderly list, solve a simpler problem, consider special cases, or use a formula. So each of us have own strategy to solve a specific problem. So for me, I think my strategy is look for a pattern and also try to work backwards because sometimes at the end of the problem there is a clue or a hint what will be the step or what will be the solution that you need to make. The next principle is solve what you have planned. This step is usually easier than devising in the plan. In general, all you need is care and patience, given that you have the necessary skills. Persist with the plan that you have chosen. If it continues not to work, discard it and choose another. Don't be misled. Think about it again. Carrying out your plan of the solution, check each step. Can you clearly or can you see clearly that this step is correct? Can you prove that this is or it is correct? Next, and the last principle is check your answer. Polya mentions that much can be gained by talking or taking the time to reflect and look back at what you have done, what worked, and what didn't. Doing this will enable you to predict what strategy to use to solve for future problems. So these four four principles of Polya's method taught us that in every problems, not just a mathematical problems, or it can be in real life problems or in any problems, there is a specific ways that you need to do for you to be able uh, not to foresee the important things, especially the given and the problem itself. If you really understand the Polya's method in problem solving, try this. Kim's class voted on a location for a field trip. 3/8 of the class voted for Science Museum. 9/32 of the class voted for the water park. The rest of the class voted for the zoo. What fraction or percentage of the class voted for the zoo? So I want you to try this on your own and then uh, with the use of four Polya's method. For the additional terms, the conclusion formed by using inductive reasoning is often called a conjecture, since it may or may not be correct. So this is only for inductive reasoning. A statement is a true statement provided that it is true in all cases. If you can find one case for which a statement is not true, then it is called a counterexample. Then the statement is a false statement. So I hope you learned a lot for today. Thank you so much for listening and watching this lesson presentation in problem solving for technology. Thank you so much.